Let's look at another example. We have two wires A and B made of the same material and having the same length. Okay, as we write down the knowns and unknown variables, we use the subscripts A and B. So they have the same material, means they have the same resistivity and they have the same length L. Okay. The resistance of A is given, right? So we write that down. Resistance of subscript A, 25.8 ohms. Calculate the resistance of B, and that's our unknown with a question mark. Diameter of A is twice that of B, so we write down the ratio. Diameter of A over diameter of B is equal to 2 times. Okay, now we are ready to use the EPR method. E for equation. Resistance is equal to resistivity times length over area. Since A is already given as a label of a wire, we'll spell out area to avoid confusion. Next, we have proportional. Resistance is proportional to resistivity is the same and length is the same, so we can ignore both and write down the area. However, area is expressed in terms of diameter. So in our original equation, write down area as pi d squared over 4. And therefore, for proportional, resistance is inversely proportional to diameter squared. Finally, ratio. Okay, the ratio of resistance. We are interested to find resistance of B. So write resistance of B first over resistance of A is equal to, is inversely proportional to the diameter. So diameter of A over diameter of B. Okay, so BA, AB, and do not forget the square. Okay, and then we can move on to the calculations. Resistance of B, this is the unknown, and write down the rest of the variables on the right side of the equation. Multiplied by resistance of A. The ratio of the diameter of A to B is known, it's 2 square multiplied by resistance of A is 25.8 ohms. So we can use a calculator and determine that this is 103.2 ohms. Okay, so our final answer to 3SF will be 103 ohms, or 100 ohms to 2SF.